Hello everyone, we continue to study the Z-domain analysis module of discrete systems. The sixth part, Z-domain analysis method for discrete systems. Section 5, Inverse Z transformation power series expansion method. The principle of the power series expansion method is as follows. According to the definition of Z transform, the Z transformation can be expressed as the form of a rational function of Z. We express it as the following formula, x of Z. According to this expression, we can use long division performs the corresponding inverse transformation. Then you can see that after long division, we can expand it into the form of a power series of Z according to the definition of Z transformation. Then, through this definition, you can see this coefficient of power series is the original sequence x of k of the inverse Z transform of x of Z that we seek. This is the basic principle. Then let's look at a specific example. The expression of a sequence Z transformation is known as x of Z. The modulus of the convergence domain is greater than 1. Find the original sequence x of k. Then first, we analyze its convergence domain outside the circle. That means it is the form of a sequence on the right. According to the definition of Z transform, we can express it as a series form of this form, which is the series of Z. We use the descending power arrangement. Let's perform the corresponding long division operation. The calculation process and the results are as follows. You can see we can make further calculations based on this formula. Then, after getting the expression of the descending series arrangement of x of Z, according to the definition of Z transformation, since x of Z equals to x of 0Z plus x of 1Z to the power of minus 1 plus x of 2Z to the power of minus 2. Keep adding. Add this combination of the following items. So we can see from the above expression the form of this original sequence of x of k. Then the corresponding coefficients of this power series are 1, 2, 3, and 4. Then you can see inside, when k is equal to 0, its result item is 0. So the constant item is 0. The result we seek is this corresponding expression. Then, in the process of solving the inverse Z transform using power series, depending on the convergence domain, we can divide it into the form of right sequence and left sequence. Then, in this example, since the convergence domain is outside the circle, the result is the form of the sequence on the right. This is when we continue to decompose later, a case of inverse Z transform of the right sequence. Then, according to the example above, you can see that x of Z is arranged in the form of the descending power of Z. This is the corresponding result obtained by power series expansion. Let's review this example just now. You can see, according to the convergence domain, the form of the inverse Z transform obtained is the form of the sequence on the right. it corresponds to the form. When we find the inverse Z transform, there is also a form of the left sequence. X of Z is arranged in the form of ascending power of Z. Then the result of the arrangement is as shown in this expression. That is, k goes from negative infinity to -1, the corresponding expression that sums up. Then all its items start from x of -1. We look at the corresponding example. The x of z expression is as follows. Since the convergence domain is the modulus of z, which is less than 1, then we can determine that it is in the form of a left sequence. We deal with it by the corresponding long division, then get the ascending form of z. This kind of power series expansion. So its corresponding coefficient of each power series of z is the form of the inverse Z transform we require. Then the original sequence x of k is equal to 1, 2, 3, and 4, extending all the way to positive infinity. Then we write it in the form of this data expressed like this. When k equals to -1, it is the first term. Its function value is 1. Today, we have learned the expansion of the power series, as well as the inverse Z transform. There are mainly two forms. According to the difference of the convergence domain, it is divided into the right sequence and the left sequence. Please pay attention to all of these contents. Thank you. That's all for this lesson.